experiment was the effect of cold on golf balls. For this experiment, my hypotheses, or my question statement was, what is the effect on the bouncing ability in number of bounces when golf balls are frozen? I predicted that the golf balls will have much less bouncing ability in the number of bounces when they're frozen. For this experiment, I used just regular recycled golf balls. And 10 room temperature. The temperature here was 72 degrees. So these were out for actually about 48 hours in 72-degree temperatures. And 10 frozen golf balls that were in the freezer at around 10 to 15 degrees for about 48 hours. Also, what we needed for this experiment was a yardstick. Part of the experiment that was really key is the vocabulary, because we wanted to learn more about density and heat energy and the effects that these things have on the elasticity of the golf ball. So our key vocabulary included contract, which means to decrease in size, expand, which means to become larger, heat energy, which is the result of the movement of atoms, molecules, or ions in solids, liquids, and gases. And heat energy can also be transferred from one item to another. Another key vocabulary word, density, the degree of compactness of a substance. And finally, elasticity, the ability of an object or material to resume its normal shape after being stretched or compressed. The variables for this science experiment were the temperature of the golf balls was the manipulated variable. Again, we had the room temperature golf balls and the frozen golf balls, 10 of each. Our responding variable will be the number of bounces per golf ball. And then our constants are the room temperature. Again, the temperature here is a constant 72 degrees. And these are standard recycled golf balls, all the same type of golf ball. And each ball will be dropped from a height of 36 inches. So those are our constant variables. Those won't change regardless of whether we're using our frozen or our room temperature balls. Again, materials, our golf balls, 20 in all, freezer, yardstick. And what we did for this, again, we froze 10 golf balls prior to the experiment. We dropped each of the non-frozen golf balls from a height of 36 inches and counted the bounces. It did get a little hairy when those bounces became much smaller, but we dropped all 10 and then recorded the number of bounces for each one. And then we took the other balls from the frozen balls from the freezer and dropped each of those one at a time for, again, a distance of 36 inches. And the difference that we saw in the number of bounces we'll go over shortly, but we did that again with all 10 of the frozen golf balls. And the floor was the same for each. It was a tile floor, a hard tile surface, and again, 36 inches and the room temperature the same. We found as a result of our experiment that the average number of bounces for the room temperature ball was 21.2 bounces. The average number of bounces for frozen balls was 11.3 bounces. And so our conclusion for this experiment was that when golf balls are frozen, the inside contracts and they become more dense and less elastic. The effect this has on the balance of the balls is that the frozen balls will have less balance. So when our balls are frozen, they will become more dense. The molecules in there are more compacted, and so there's less elasticity. When we have our room temperature balls that have more elasticity, there was more balance. Now, one of the real-world applications for this, there are many ways that you can look at this experiment and use the information, but for a straightforward practical application, we can talk about golfers when they are in real-world situations and they're in cold weather. This is going to have an effect on when they swing that golf club and hit that ball, how far that ball is going to go if it's very cold outside. Those balls are cold and they're more dense and less elastic. And that is the conclusion of our science experiment.